Welcome back everyone. In this session, let us discuss about the implementation of logical and logical R with the help of single layer perceptron. So in the earlier session, we have seen the architecture of this. So now let us do one practical implementation. So here the initial weights that we are taking, W naught we are taking as minus 0.8, W1 and W2 we are taking as 0.5. So as we know, x naught is always 1. So by default, we are taking the x naught value as 1, right? And all of you know the truth table for and also. I hope so. So this is the truth table for and. Whenever it is 1, 1, only in that case the output is 1. In rest all combinations, it is 0. So now, what is the formula for single layer perceptron to get the output? First of all, we have to calculate the summation, that is sigma wixi, which is expanded as W naught plus W1 x1 plus W2 x2. So here, how many number of inputs do we need? We need only two, right? X1 and x2. So only the formula we are limiting up to the third term, W2 x2. And this output will be given as an input to the sine function or the activation function, which will give us the final output, right? O of sigma wixi. So what should be the outcome? If this wixi is greater than 0, then we get an output of 1. Otherwise, we get an output of minus 1 or 0, right? So this is what we have seen in the earlier definition. So now let us work with the first input values, that is x1 is 0 and x2 is also 0. Substitute in the formula sigma wxi, let us calculate first. Okay. Minus 0.8 into 1 is minus 0.8. So I'm not showing that multiplication here. Directly I have given. Next, 0.5 is the W1 value multiplied with input x1, that is 0, plus 0.5 is the W2 value multiplied with x2, that is 0. So now, if you simplify this, the value that you will be getting is minus 0.8. So now what should be done? This output should be given as an input to our sine function or the activation function. So this sign of this is, sorry, I have written it as a spelling, it is SGN, sine function. So sign of this is 0 because wixi value is less than 0. So we are taking the output as 0. So if you see the representation of this, we are taking only two inputs, x1 and x2. So here x1 value is 0 and similarly x2 value is also 0. So this is the input that we are supplying to this, and W1 value is 0.5 and W2 value is also 0.5 and W naught by default we are taking it as 0.8 and x1 value is anyhow 1. And here calculation of the sigmoid, the output of this we got as minus 0.8, which we are giving as an input to our sine function. So the final output that we are getting is a 0. Our output is 0. This is how your AND representation for the given inputs will look like. Now let us go with the next set of inputs, that is 0 and 1. If you simplify this, you are getting a value of minus 0.3. And if you give it as an input to this, the output is a 0 because you are getting value as a negative 1, which is less than 0. So it is 0. This time, x1 value is 0, x2 value is 1. Again, this W naught remains the same. W1 is 0.5, W2 is 0.5. Summation we have done. The output of the summation is minus 0.3, which is going as an input to the sine function. So if this value is greater than 0, our sine function will generate a 1. Otherwise, it is going to generate as a 0. So the final output is 0. Similarly, let us work with the next set of inputs, that is 0 and 1. Sorry, 1 and this is 1 and a 0. This time x1 value is 1, x2 value is 0. Rest all the values are the same, that is minus 0 0.8, 0 0.5, 0 0.5. Output of the summation is also same, that is minus 0 0.3, which we are giving as an input to our sine function, which is giving us an output of 0. Next, let us go with the last set of inputs, that is 1, 1. This time, our last fourth row. X1 value is 1, x2 value is also 1. So if you substitute and if you simplify, sigma wixi is 0.2. And when you give this as an input to the sine function, the output that it is generating is 1 because 0.2 is greater than 0. So output we got as 1. 1, 1. The weights are the same, 0 0.5, 0 0.5, minus 0 0.8. So the output that is processed at sigma wxi that we got is 0.2. And when you are giving this as an input to the sine function, see the representation, the output is 1. I have just tabulated all these values for you once. So these are the values that we have obtained. Okay. So now let us cross verify with the truth table whether we got it correctly or not. So in the first case for 0, 0, we got the output 0. Yes, matching. Next, this is the actual output. So here I would like to introduce you one more term also, the actual output and the predicted output. In this case, the output is 0. In this case also, the output is 0. In this case, the output is 0. And only in the last case, the output is 1. So that's what we have computed earlier. Okay. So all these values we call as predicted ones. The output that we have computed, we call it as predicted output. When we say the training is successful is whatever we are expecting. That means if the actual output and the predicted output, if it is matching based on a given threshold, then we say our training is successful. So now here you can see for the first set of inputs, here we are expecting a 0, we got a 0. Next for 0, 1, we are expecting a 0, we got a 0. Next for 1, 0, we are expecting for a 0, here also we got a 0. Next for the next set of inputs 1, 1, we are expecting a 1 and the output that we got is 1. So that means our neural network or our single layer perceptron is working perfectly. So I can fix these weights. So actually these weights are already tried for n number of times and finally this was confirmed. So now as a trial, if you want, you can just slightly change the values of this W0, W1 and W2 and check whether you will be getting the same value or not. Okay. So if you are not getting the same values, again, you will be changing the weights. So that is how the learning will happen, that we will be seeing in the next session. Okay. So with this, the implementation of AND is done. Next, let us see the implementation of R. Before going to the next implementation, I request you all to pass on these videos to all your friends who are in need if you find this content as useful and informative. And also do like, share and subscribe my channel too, which will be an encouraging for me. Next, this time here you can see W0 I have taken as minus 0.3. And W1 and W2 I took the same value. And this is the truth table for R. If it is 0, 0, we are expecting a 0. 0, 1 is 1. 1, 0 is 1. 1, 1 is 1. So you all know this truth table, right? So let us use single layer perceptron to solve this. Again, this is the equation for the sigmoid. Now also I have only two inputs. So I need only three terms. W naught, X naught I am not mentioning as its value is 1. So directly I am writing W naught, W1 X1, W2 X2. Now let us try with the first set of inputs, that is 0, 0. Then sigma WXI is minus 0.3. So which will be given to the sigma sine function. So output of this minus 0.3. What will be the output? By this time you have got enough expertise. You can answer. What will be the output? It is 0 because the value is not greater than 0. Next, for the next set of inputs, that is 0 and 1. Sigma WXI value is 0.2. So when you are giving this as an input to the sine function, sine of 0.2. Since this value is greater than 0, we will be getting an output of 1. Next, 1, 0. The value of WXI is again 0.2, similar to the earlier case. So the output of this is also a 1. Next, X1 is 1, X2 is 1. If you multiply and if you summate, WXI value is 0.7. If you give it as an input to the sigmoid function, since 0.7 is greater than 0, what is the output? The output is 1. And our single layer perceptron network will look like this. This is our X1, X2, and here we have the weights. This time this weight is 0.3, 0.5, 0.5. This is our summation, whose output is given to this sine function. If the value is greater than 0, we are getting an output of 1. Otherwise, we are getting an output of 0. So let us just verify whether we got the expected output or not. Okay. So this is the actual output or the expected output. What is expected? Expected is 0. What we got here is also a 0. Here expected is a 1. Here I have written 1. Since the sine value is greater than 0, the output of this, okay, here I have written, the output of this is 1. So, okay, tallied. Next, in the next case also, output is 1, expected is also 1. In the next case also, expected is 1, calculated 1, or predicted 1 is also 1. So here, both the actual values and the predicted values are matching. So our training is done. So finally, these weights are fixed. So usually these weights will be picked randomly between -1 to +1. So you can choose any value between -1 to +1. And similarly, you should cross verify. So whichever weights are giving you this expected output, whichever weights are matching with these expected outputs, that we will fix as the final outputs. Okay, so that we will see in the next session, that is training, perceptron training. So hope you followed this video. If you have any queries or if you need any other topics or the practical implementation of this, let me know in the comment section. Thank you.